Okay, so this is going to be a really quick intro to the triangle inequality theorem. And really, what we're trying to do here is answer a very similar question as before in another video. It's does it form a triangle? Okay, so in the other video, I showed you how to do it using the circles and using the little shortcut there. But in this video, I'm going to go ahead and show you how to get the exact same answer, but using the triangle inequality theorem. It's completely up to you, whichever way that you decide to use. So the theorem. The theorem basically just states that if you actually have a triangle, so if you do have one, then what's always going to happen is if you add two, any two, it's always greater than the third one. So in my shortcut, I say, look at the two shorter sides and then compare that to the largest side. But what the theorem says, it makes it just way bigger. It just says, you know what, don't even care about which one is the shortest, longest, medium, whatever. It just says add two sides and it has to be greater than the third side. And it's true for every single side. So for instance, in this triangle here, you notice how I called the sides ABC. So just choose two sides. It doesn't matter at all. C and B. I'm going to choose two other ones anyways after. So what I say is C plus B. So that's two sides to add it together. It has to be greater than the third side, which is the one I didn't use, which is A. So that is right there one inequality. Now, if I go ahead and I decide to choose two different sides, let's say A and B. So I'll go ahead and say A plus B has to be greater than the third side that I did not use, which was C. So that's the second inequality. And then finally, the last one is just think about which two sides have you not used, C and B. So what that means is, sorry, I already actually used those two, C and A. So then what that means is I'll do C plus A has to be greater than the only side I didn't use, which was B. So that right there is the inequality, the triangle inequality theorem. It basically gives you three different inequalities that you can work with, and all of these, it's really important. All of these need to check out, need to be considered true in order for a triangle to actually exist with the three numbers that you're using. Okay, so let's go ahead really quickly and see how can we use this for pretty much the same type of problems. So does 3, 4, and 5 form a triangle? Well, those side lengths form a triangle. So all you have to do is form three inequalities. So three inequalities based off of the inequality, the triangle inequality theorem, and every single one of them has to be true. So choosing two at a time. So 3 plus 4, is that bigger than 5? So 3 plus 4 is 7. So is 7 bigger than 5? Yes, it is. Okay. Then we just choose two other ones. Let's use 3 and 5. Is 3 plus 5 bigger than 4? 3 plus 5 is 8. Is 8 greater than 4? Yes, it is. And then finally, the last one, just choose two sides that you haven't used before. So that's going to be 4 and 5. So is 4 plus 5 bigger than 3? That's true as well. So notice how we got three trues. So therefore, does 3, 4, 5 form a triangle? My answer comes out to be yes. So the triangle inequality theorem is just a very mathematical way of trying to see, does it form a triangle? So here you go. Does 1, 1, 10 form a triangle? Three inequalities, okay? Choose two sides. So 1 and 1. Is that bigger than 10? We get 2 greater than 10, and this is false. So this is not correct. So what that means is that I actually can stop here already. I don't need to check the two other inequalities because one of them came out to be false. This false is really important. You only need one false to make it a no. It cannot form a triangle, okay? It doesn't matter if the other two are true. You only get one false and that's it. And in fact, you will get two trues, right? The other ones will be true. Let me just show you. So 1 plus 10, is that bigger than 1? So that's 11 greater than 1. So that checks out. And then we have this one in the front and this 10. So you have to be careful there when you have sort of an isosceles, quote unquote, because it's actually not an isosceles, but whatever. So we'll do 1 plus 10. Is that bigger than the other one, the one in the middle that I did not use for this third equation? So 11 greater than 1, and so that checks out. So you just have to be careful when numbers repeat, okay? Choose a different color or whatever. So if you notice, you get two truths and one false. Sorry, two truths and one false. and that's automatically a no, right? You don't have to really do these other two if you already got a false, okay? But that's just, just because I wanted to show you. For those of you that really understand the circle way, this is extremely easy to see why it's a no, right? You're basically talking about like there goes a 10 and you're talking about a 1 and a 1 here, your two little triangles. There's no way those are going to intersect. But whatever. It's completely up to you which way you want to do it. So this right here, right, is the theorem. One false, that's all you need. You look for the one false, and then that means it's a no, okay? And then the other way is you have to get the three of them as true or valid in order for it to create a triangle. So these are the four same examples as before. Go ahead and from the other video, so go ahead and see if you can do it now using the triangle inequality theorem. I'm only going to do the first one, and then you can go ahead and do all of them. You already know the answers if you look at the other video, okay? So let's go ahead, and for number 1, I'll choose just two random sides. So 10 plus 11, is that greater than 7? This is 21, so it's true. Choose two other numbers. 11 plus 7, is that greater than 10? That's 18, so that means that's true. And then just choose the two numbers you haven't used, which is 10 plus 7, is that greater than 11? Which it's true. So we have 3 true, so then that means this is a yes, it will form a triangle. Okay, I'll go ahead and put the answers for all of them. You can do it using the triangle inequality theorem and see if you get something that you're supposed to get. So that's a no. Number 3 is also a no, and then number 4 is a yes.